So I'm going to talk about New York Harbor as in the adjacent embayments as a case study. A couple literacy principles. New York Harbor and Long Island Sound are geographically unique. New York is one of the world's original coastal megacities. The harbor's been highly modified. The Long Island embayment eutrophication stimulated the limiting nutrient paradigm. The first description of DDT magnification was in Long Island Sound embayments. Long Island embayments, sorry, and strong water quality gradients with improving water quality are present in New York City. And New York Harbor and waterways have been key to the development of the city. So the geographic nature of New York Harbor and Long Island Sound. New York Harbor is adjacent to the bight of the Atlantic Ocean, so there's a north-south coastline to the south and an east-west coastline to the east, and so it's right at the juncture of those two geographic concentration, and it's situated at the mouth of a major river, the Hudson River, head of a major estuary, Long Island Sound, which is a couple hundred miles long here, and dotted with lots of islands and surrounded by coastal lagoons. Long Island Sound is an estuary in which the largest river is not the head of the estuary, but toward the mouth of the estuary. That's the Connecticut River extending all the way up into Canada. So they're both quite unique geographically. So New York Harbor is a great geography for a safe harbor. There's the Rockaway and Sandy Hook here that provides the outer harbor, and then Verrazano Narrows, and then the upper bay or inner harbor here. So ships can get out of the Atlantic Ocean and find refuge in these waterways. Lots of estuarine resources. Jamaica Bay over here, Raritan Bay, Sandy Hook Bay, Newark Bay, and then western Long Island Sound. And so there are lots of marshes and embayments historically. Now, going back to this map, I'm going to just take such a complex area. I'm going to do this with four transects, a north, all these transects going from west to east, through Manhattan and Bronx, down at the lower Manhattan, across the inner harbor here, and across the Verrazano Narrows. And so these are the transects. You can see the bluffs, the highlands of New Jersey, deep Hudson River with sturgeon and lots of tidal flushing and toxicants. Manhattan, tip of Manhattan Island, and the Harlem River, which is turbid. The Bronx, the Long Island Sound, both East Chester Bay and the Sound proper, with oysters and sand deer sediments, lots of recreation over to Long Island. And then south going through Midtown Manhattan, that's the Empire State Building here, we can see New Jersey with lots of fill here. So this was, Hudson River was much wider historically, and it's been filled both on the New Jersey and the Manhattan side. The Lincoln Tunnel and the Queens Midtown Tunnel going underneath the Hudson River and underneath the East River connecting Long Island Sound with New York Harbor, and Brooklyn here with also some fill on that coastline. And then the transect through the Statue of Liberty, we see Newark Bay, lots of toxic buildup, dioxins in particular. Bayonne, large shipyards here, and the harbor, the skyline with Freedom Tower in the background, lots of ferry traffic, lots of fish, turbidity. Increasing over on the east side near the East River, we have Governor's Island, the Brooklyn Battery Tunnel, Buttermilk Channel, which used to be very shallow, which is now scoured and deeper because of dredging and restricted flow that causes more scouring, and then Brooklyn. And then finally, the southernmost is Verrazano Narrows Bridge connecting Staten Island with Brooklyn. Here we have Arthur Kill and ship activity and port development. Jamaica Bay, a very shallow coastal lagoon, except for dredged areas. It's the home of JFK Airport. It's also a national park, and then the suburb of Queens, or the borough of Queens. So New York is one of these original mega cities. Tokyo and New York were the first two 10 million population, 1950. Of course, lots more have occurred since then. It's been highly modified, and if we look at Manhattan Project, in which they've looked at old charts and maps, and they can see the original outline of Manhattan Island. You can see lots of marsh and a very skinny, narrow tip here, which is now all rounded out by landfill. So New York was a very low-lying, marshy area in most parts. So lots of dredging and filling, lots of dredge channels. Now we have massive wastewater and stormwater inputs and various invasive species that have occurred. The water supply into New York Harbor, into the New York metropolitan area, comes from quite far. It's up in the Catskills, where these watersheds have been maintained to provide good drinking water and large, extensive aqueducts down into New York City. The Long Island Sound embayment eutrophication story. These are Jamaica Bay here, and then this is called Great South Bay and Riches and Shinnecock Bays along the South Shore coastal lagoons. And starting in the 1930s, there was a huge program of creating duck farms, and they always raised the ducks adjacent to water so that at the time they felt that ducks needed water, and they produced 4 million of these ducks. And this inlet got blocked up, and they had these huge green tides, these blooms that were that came through, and it led to the decline of their blue point oysters. And these little green forms were causing real problems in water quality. And it was because of this inlet being closed off by a large hurricane and then trapping that water and the nutrients from the duck runoff. So they got a guy from Woods Hole, a guy called John Ryther, to come down and investigate this eutrophication. And so Ryther looked at this with bioassays, and at the time, this was right after the Lake Erie and the phosphorus ban. Everybody was focused on phosphorus as a major limiting nutrient, and what he showed with these bioassays that was the nutrient was stimulated, the growth of the plankton was nitrogen, not phosphorus. And then he followed that up by taking the Atlantis, the Woods Hole oceanographic ship, and on these 3 transects out of New York Harbor, across the continental shelf into the Sargasso Sea. And what he saw was that the distribution of nitrogen dropped away much more quickly than that of phosphorus, and provided a classic paper in science that pointed to nitrogen as a major limiting nutrient for coastal waters. And then another key was in the DDT, and this was done out of Brookhaven, a national lab in Long Island, and looking at the sampling the various food web along in this part of these embayments here of Long Island. They found this DDT bioaccumulation, published in Science, and of course, since then DDT has been banned. So looking at the harbor itself, zooming in on this with some data that we've just recently obtained from the New York Harbor Project, and calculated these scores for water quality scores using the same technique we did for a Long Island Sound report card. What you see are these canals that Newport Creek, for example, here, Newtown Creek, sorry, and other places where the restricted water is very degraded water quality. The best water quality ducking out from Rockaway Point over here by Coney Island. Good water quality, good flushing, from the Coriolis effect, the water coming in from the oceans, very clean. And then poor water quality over in New Jersey. Lots of rivers, the Hackensack, the Raritan, the Passaic, coming over here from New Jersey, so they're with lots of runoff. Jamaica Bay, reduced water quality as well, and the western part of the Sound and East River. And that makes sense given the sort of the gradient in Long Island Sound, which is very well flushed from Block Island Sound with large tidal flushing in the eastern and central portions, but as it narrows into the western, narrows with the New York City inputs, degraded water quality. So some trends, however, this is some trends from the New York City DEP, Department of Environmental Protection data set, and they've sampled here in the Hudson and the Upper Bay, and then along in the Arthur Kill here, and you can see combining these data, what we see is improving dissolved oxygen both in surface and bottom water, improving bacteria. Of course, this is not directly following rainfall where all those numbers shoot up and it's not safe to swim. Declining total suspended solids. And yet, and this is similar to the Chesapeake Bay where the transparency, the water clarity based on Secchi depth is declining, even though the suspended solids are improving, and in some cases chlorophyll is improving. So there's a little bit of enigmatic water clarity decline that's going on. So this harbor and the waterways surrounding New York have been key to the development of New York City. So this ecological diversity and richness around this harbor have supported the economically rich and diverse and vibrant city that New York City represents. The oysters in Menhaden have provided the protein and the crop fertilizer. So oysters, and I'll talk a lot more about oysters in a minute, were key. They did a lot of Menhaden fishing, and they used that to fertilize the crops in Long Island where they had their vegetable gardens until they started growing houses instead of crops. The protected waters made for good shipping. The Hudson River connected eventually to the Mississippi basin through the Hudson River Erie Canal, and then Long Island Sound was the major entrance into New York Harbor until late 19th century when steam-powered dredging made the ocean approaches navigable, but the shoaling offshore had prevented that, so people went the back door through Long Island Sound. And then the marshes provided great opportunity for not only the ecosystem services, but then for land growth, and so there was a lot of filling that went through that. So let's talk about oysters a little bit. You don't think of New York City and oysters much, but there's a good book called The Big Oyster about the history of oysters in New York, and these are some barges along the Hudson River that were all just oyster restaurants. In Fulton Street, they had these open oyster stands. Oysters were huge in New York City. They were a big part of early development in New York. They're very plentiful. They sustain native populations before the European settlers, and they were finally overfished in the 1800s. And so the concept is to try to recreate some of this. So there's a project called the Billion Oyster Project, which we're involved with, and it talks. We set the setting is that it's a unique setting. We've talked about it. It's a diverse city, culturally and economically rich, diverse, and vibrant. It's a highly modified harbor with a modified shorelines and invasive species dredged channels. It's got huge engineering works around it and opportunity to change this. So this project's focused on the education program using oyster cages and school groups, and so all those 5 boroughs, the kids can walk from local schools or waterways, generally within walking distance of most of the schools, and so that they can go and start putting those out and put those oysters out. And you can see the numbers here that have been so far put out there. And then, and interestingly, the whole concept of Billion Oyster came from the Horn Point Hatchery, where they've a few years ago hit 1 billion oyster spat produced. So that was the goal for the New York Harbor. Picked up on that. And they're even using recycled toilet porcelain to to put out these oysters, but they put out these bags and then retrieve them. Um, and so one of the issues that really important about New York Harbor, it's vulnerable to inundation and sea level rise because of climate change, and that was really illustrated when Hurricane Sandy came in 2012, with lots of destruction of infrastructure, uh, uh, a few deaths, and the lack of oyster reefs and natural marshes have affected that resiliency. So for integration, for New York, two good books I'll recommend: Heartbeats in the Muck and Gotham Unbound, these environmental histories. Of course, I already mentioned The Big Oyster, which is a fun read as well. The precautionary principle, and I think the best example of that is in the water supply. So when New York Harbor or New York City was looking to uh, develop infrastructure for water treatment, they recognized that if they protected the reservoirs up here in the Catskills, then they wouldn't have to spend as much money in treatment. So they bought up a lot of this land and created these large aqueducts that come down into the city. Another, the Croton watershed and the Catskill watershed, with these huge aqueducts that stream all the water, and even in Hurricane Sandy, and it's done by gravity feed. So even during Hurricane Sandy, New York had safe, reliable drinking water, even though the power was out. Sustainability and resilience. So New York City groups are trying to develop more resilience, and so you can see some of these uh, shoreline developments. They're trying to cope with inundation, sea level rise, get more people out on the harbor. There's a lot more activity on the harbor these days. You can see that the Sandy had this huge pulse of wastewater that was treated. So a lot of it was untreated, though. So even with this pulse of treatment, there was a lot of raw sewage that ended up uh, in the harbor, and so lots of infrastructure post Sandy is set up to try to avoid those overflows. So for a quick reference, I've got a paper that we wrote recently on resilience of New York Harbor in the face of 4 centuries of development, providing some um, environmental history, and also recommend to you the State of the Estuary 2012 report. The more recent ones don't have much data and they're kind of fluffy, but this one's, I think, the best place to go to look into some of those trends.